Okay, practice problem 7.7, millimeters, grams, and seconds. Hard? I'm not seeing this one as being too hard, but let's go with it. Part's origin is at the bottom. All right, so kind of the interior of the flange. Asymmetric sketches are fully defined line circles, center lines, extrude boss, revolves, fillets, and chamfers, circular pattern. All four blades are evenly spaced. So kind of a wood insert for a threaded fastener. Let's go ahead and get this started. Based on the isometric view, kind of thinking that we need to be drawing in the right plane, but yeah, we'll go ahead with that. First instinct, and to get it to look like the isometric view, yeah, their sketch origins and the other origins don't really line up to what I'm thinking on the isometric. So I'm going to go with my first instinct. If you do something different, that's fine. Let me know how it works out. All right, so we're going to be drawing the interior shape, and then that's going to come back this way. And go back some that way, and then we'll put make sure I'm getting that continuous, and then these two will be concentric, and I want to make sure that I have tangencies on both ends, so tangent, tangent, and no tangent. So let's get that one in there. All right, so we have a 1 millimeter, and that should carry through. The outside is 25 millimeters. Okay, the inside then is 8 millimeters. And our overall height is, make sure that I'm getting the overall height. So let's escape to get out of the diametral. And we'll go 12. And then our interior radius is 2. And so if we do the outside, it should be overdefined, but we can verify that it is actually 3. All right, we're fully defined. We're ready to revolve. Blind 360 degrees. So now when I go Control 1 to the front plane, we can start our sketch. We'll just start it on that face. And I'm just going to go with a rectangle to generate the notch. And we have a distance of 3, the center, and 9 on the vertical. Okay, so yeah, that looks pretty good. Can just bring those back coincident or tangent, something that makes that notch. All right, need to double check my numbers. 3 on the vertical, and that is to the inside, and they're not really showing a bend. If it was sheet metal or something, we'd kind of expect a bend, but they're showing that as a sharp. So 3, 9, and then this one would be, yeah, that goes to 10. So yeah, that looks like the cut. All right, features extrude cut through all, or up to next is fine. So we get the cut in there, and so that looks like it's to the outside, so we open up the sketch. We're gonna do that one, and then possibly it's gonna be tangent. Well, let's go ahead and bring it out to that point. And because the section view would be just behind it, I'm going to assume there's a little bit of a line there, so I'm going to assume that that goes that way, and we'll just go tangent. And when I go Control 8 normal 2, we need a height from this face to the tip is showing at 9. All right, so let's go back to the isometric, Control 7, extrude, not midplane, not 10 millimeters. Let's go to the 1 millimeter and show it. So that looks pretty much like it. So let's go ahead with the circular pattern, pick something, and go ahead and accept it. Oh, and there's 4 of them, so that would probably help. 4. All right, that's a wicked looking little, okay, so the problem with this is that length is only what, 4.6, so unless you do something really strange with that, that cut and that shear and stamping to get that bend, yeah, that's going to be an interesting piece to manufacture. All right, so 787. Let's go ahead and save this. P7-7 and evaluate and mass properties. 770. All right, close enough. All right, let's go back, just a quick overview. Three, 2, 9, 1, 12, 8. All right, nothing jumping out at me as anything that I really missed, so we're close but off by a little bit.